Hello, in this video tutorial, we briefly talking about the clock and how the behavior level of code work. So in this code, we use the internal clock that came from the wiht port. So if you look back to the FPGA board and in the W5, you will see the clock, the internal clock of 100 megahertz. So because the 100 megahertz is too high, and you cannot use that directly into the directly to blink the LED. So we will dial down 100 megahertz into 155 hertz of frequency, and we're going to use the counter of 26 bit. So this is the clock calculation. Original frequency is 100 megahertz. Then we're gonna divide it down by using the 26 bit. Now we got 1549 hertz of frequency output for each LED to blink. So this is how each clock related frequency work in here, this bit. And this is the overall calculation of it. And if you see the most significant bit of 25, which means for every input waveform, we're gonna blink one in most significant bit. And since our counter has the most significant bit value of 25, by using this formula, we calculate how much the output frequency will be. So to summarize about the clock, we use the internal clock of 100 megahertz and we dive down into 1.5 hertz in order for the LED to blink, because 100 megahertz frequency is too high. You cannot use it directly. In order to dive more into the coding part, this right here is where we define the input that we are using. So this particular line of code is where we provide a logic, basic logic type as a std further, and this line of code is where I provide the parameter on assign and sign types in order for increment the counter, because we need the clock to be working. And about the entity declaration, we have two in the position. One is the clock, which is the internal clock, and the other is the LED. And since we got 16 LED, we declare 15 auto 0. 16 plus 1 equal to 16. And just to mention in here, there's an error in this code, but not to worry, the code that I inputted on GitHub is a free working version. The entity name Blinky and the file name Blinky is different. So this Blinky without an E should be matched with this. So you either change the file name Blinky without E, or you just include an E in this Blinky, and it should be fine. And just for notice. That's why, in order to reduce the confusing, in my first video, I mentioned to keep all the names the same. And the entity name and the file name is really important as well, as I mentioned before. Okay. Next, I will be talking about the behavior, or the architecture and counter signal. So we assign a signal as a counter, and it count in every 26 bit, because 25 plus 1 equals 26. And in this part, counter equal counter plus 1 is where the looping begin, and it's logic the count in order to produce a wave like this. So if every rising edge of the clock means this is the rising edge. Sorry, this one. The counter will count plus 1. And it will send, it will notify the count, notify the LED, and then blink. So that's all in this video. And thank you so much.